here I write x plus h and then minus x plus h again. Alright, I expand, that becomes 2, it's 2 is still outside, that becomes x squared plus 2xh plus h squared minus x minus h. Now if I distribute the 2, what do I get? I get 2x squared plus 2x, plus 4xh plus 2h squared minus x minus h. My next step is going to be to write down that one minus x. What is left here? That one cancels out. I'm basically left with my average gradient is equals to 4xh plus 2h minus h. We good with that? Wait. 2h. Thank you for that. Now, once again, this is just my preparation. I haven't answered the question, but I need this, and this is eventually going to make this a little bit shorter for me. Now, the question was determined from first principles. Writing down here, f of the derivative of f of x is equals to the limit as h approaches 0. Now, because this is on the formula sheet, they're not going to give you marks for it. No? But it's important to write it down, because to eliminate mistakes. So therefore, write it down, f of x plus h minus f of x over h. First step there is then writing down. Then second step, I already did my prep work, so now from here it's easy. I can just do the substitution, which is going to be this whole answer of the numerator is 4xh plus 2h minus h. So x squared, h squared. Yes. So just said 2x squared. Alright, over h. Next step is going to be take out the common factor, which is h. Remember to write this the whole time because I haven't done that yet. H is 0. So if I take out h, I get 4x plus 2h minus 1 over h. That one and that one cancels out. Now I'm left with 4x plus 2 times 0 minus 1. Final answer is 4x minus 1. We agree with that? Yes. Quite simple. What you need to be careful for is changing the limit and writing it on that side, because then they're going to deduct mark for notation. So watch out for that. And the reason why I'm also doing it like this, you will see, it looks as if my thing is much shorter than if you write it out the whole time. Then you need to write out the limit the whole time. Alright, so that's why I'm doing it like this, because learners tend to make notation errors or calculation errors. Let's move on. Now, we're good with the differentiation. Here's another example. I'm talking about the rule. The rule is now where we can differentiate, not from first principles, but we have a rule. We say the exponent, we take the exponent, we multiply with the coefficient, and then the exponent drops with 1. But when we do the rule, there's a few important things. You can tell me, what is the important things? There cannot be any brackets. There cannot be any fractions. No? So we don't want x in fractions. We can have a coefficient as a fraction, but we don't want the x in a fraction. And the other one is, we don't want square roots. Do we want the cube root? No, we don't want the fourth root. No, so we basically don't want to use any surds. The collection of that is surds. No? Absolutely correct. There's 3 things, I'm going to repeat that. No fractions, no brackets, and no surds. And then we can use the rule. But when are we going to use? When they say determine, evaluate, or dy or dx, anything like that, no? Then we use our rule. Then we are allowed to use our rule. But what differs from this question and what differs from another question, from the normal questions of calculus? Great answer. This one, no, when they say from first principles, they can also say another. In the older times, they wanted to sound very cool, or they think that they're talking about, in Afrikaans, it's actually a derivative from Afrikaans. They can, and ladies, this one is for you, they can also say from foundation. No? Then you don't go put on makeup. No? You don't do that. It's not that type of foundation. it means also, it's just another way of saying from first principles. And then we use the formula for that. Alright? But when they say evaluate, determine, or dy, anything like that, then we can use the rule. Alright? But I'm going to repeat for another time. When we're using the rule, what is important? No brackets, no surds, and no fractions for our x's. So there's a few examples, and this is the different ways how we can be asked it. Determine, where you have dy over dx if y is equals to 4x, or you can have the derivative if they give you the function f of x, or they can also give it to you as dx, and then they want the derivative of 4x to the power of 3, or you can be asked it like that. No? Within fraction like that. There's some examples with the answers underneath. Determine example number 2. Determine dy over dx if y is given as 3x plus 6x plus x minus 4. Then the solution is going to be there. 3 times with 3. That example is wrong, right? Oh, 3 times 3 is 9. Okay. I took 9. I was a step ahead, sorry, I took 9 times 2. Alright, 3 times 3 is 9, yes. And then 2 times 6 is 12. But every time we drop an exponent. And then, why does that, what happens to the negative 4?
Disappears.
What?
Disappears.
It disappears, so we're busy with magic here. Just disappear, we say, oh, then it's gone. Why is it so?
It is multiplied with 0.
Ah, good answer. So when we have a constant term, no? A constant term is actually x to the power of 0. So, but we don't write this down because anything to the power of 0 is 1. You see how we can do the question with you? Anything to the power of 0 is 1. If I say, go back to exponent rules, no? And I say a to the power of 2 over a to the power of 2. What? Or let's do a to the power of 3. We can do what? That's going to be a to the power of 1 because we're saying 3 minus 2. Alright? But if you look at this on another way, before we were taught this rule, we actually had it as a times a times a over a times a. That is the expansion. Then this 2 cancel out, and what do I left with? A. No? But if I have the same thing, then I'm going to say a over a is going to be 1. And that's why anything to the power of 1 or to the power of 0, because I'm saying that one minus this one is equals to 1. Mathematics, they are coming sneaking in here, grade 12 class, eh? That. So, just to get back to the question now, let's see. You answer the question of y is equals to 1. There's some more examples. What is the challenge here at this example? We have some fractions and we have brackets. So the first thing would probably be to expand the bracket, no? And then write a fraction with negative exponent. Alright, so we're going to expand. If we expand there, we get x to the power 4 minus 2 plus 1 over x to the power 4. Then we can write that 1 over x to the power of 4 as x to the power of negative 4. And now only, we don't have any obstacles. Now from there onwards, we can use the, therefore we get 4 times with 1. And then we drop an exponent which equals to 4x to the power of 3, and then that 2 falls away, and we get negative 4 times with 1, x to the power of negative 5. Example number 4, what is the challenge then? Alright, so it's the fraction, no? Tell me what, how do we simplify that? That is actually called a difference between 2 cubes. Grade 10 work sneaking in here, grade 12, no? We factorize that by using the difference of 2 cubes, and then we get x minus 1, x squared plus x plus 1. The 2 brackets are going to cancel out in the numerator and the denominator, and then our final answer is going to be x squared plus x plus 1 that we need to differentiate. So our answer to that is going to be 2x plus 1. Then our last example, what I have a challenge there for? A surd as well as a fraction. No? We're first going to simplify. We write it as x to the power of 3 over 2 minus 5 over 3x to the power of 3, and then x goes up now. So the coefficient is now 5, negative 5 over 3, multiply negative 5 over 3 and x to the power of negative 3, and then we use the differentiation of the whole thing. Let us, you want me to do the first example?
Excuse me, a maths
Wait a second.
now.
Thank you, ma'am. First example, or you want to try on your own? If you need assistance, raise your hand, I can come to you. That's why I'm here for. Alright, quickly give me that first one. What is it? 3 over 2x minus x squared over 2.
Yes.
We're gonna rewrite this. This is going to be 3 over 2 is the coefficient. X, we take it basically, we take it up. It's going to be x to the power of negative 1. And then here, what is the coefficient here? 1 over 2. That's actually negative 1 over 2. The x is already on top. Like that. That is the first step. No? I just want to read the question. They asked ty. Alright, so therefore we didn't differentiate yet. We just wrote down it in a simple, in a better way, where it doesn't have fractions, it doesn't have brackets or inserts. Now we're going to differentiate dy over dx is equals to 3 negative 3 over 2 x to the power of, if I drop one exponent, minus 2. No? And then 2 times with a half. What is 2 times with a half?
Minus 1.
Minus 1. Minus 1. But I don't have to write down that 1. So it's just going to be x. 2 minus 1 is?
1.
We're good with that? No? Now, I know the previous class told me that your teachers ask you, no? To not leave it with negative exponents. So I know, but technically, the markers in this question, and in grade 11 we always told you write with positive exponents, so you don't leave your answer with negative exponents, but the markers is supposed to mark this right at the end of the year. No? But for just, we're not negative people, we're going to write it as negative 3 over 2x squared minus x. Just getting rid of that negative exponent. No? Just to make our answer look positive. But you're not getting an extra mark or something like that. They're also not going to penalize you for negative exponents in the calculus questions. Maybe somewhere else, they might penalize, you might be penalized, but the principle, as long as you understand the principle. Is everyone done with the second one? Yes. Done?
Yes.
So let's look at the second one. It is f of x. F of x is given as x minus 5 over square root of x.
X plus 5. Plus 5.
Plus 5. Good. X plus 5 over square root of x. What is the obstacle here? The surd and the fraction. Let's go first sort out, let's do it step by step. X plus 5 over x to the power of half. Correct work. And so you know your laws of exponents there. No? Grade 11 work. We can also go, because a plus, what is a plus indicating? Separation of terms. That means this is basically a LCD. And this, that the denominator is applicable to this one and that one. So if I want to, I can go split them up, and that's going to be x over x to the power of half plus 5 over x to the power of half. You didn't have to do it, but I think it will be easier if you do it. No? So now we know, if I'm going to determine the derivative, now I have two fractions. I think it is more, but it's not actually going to, supposed to be more difficult. Then x to the power of 1. What can I do then? Subtract that half. So that's going to be on top, x to the power of half. And then plus 5, I bring up the whole exponent. That's going to be x to the power of negative half. Now I'm going to determine, remember I didn't determine the derivative yet. Only from now I'm going to determine the derivative. So I'm going to say the derivative of f of x. And it didn't say from first term, so I'm going to use my rule. I can say now half of x. If I subtract there 1, what does it become?
Minus 1.
Minus half. No? And then negative half times with 5 is equal to negative 5 over 2 x to the power of negative 3 over 2. You good? Yes. Like I said, you can leave your answers like that. They're not supposed to penalize you. No? But because we are positive people, we have a positive spirit, let's go write it as 1 over 2x to the power of a half minus 5 over 2x to the power of 3 over 2. That answer there, totally sufficient. If you want to go with the extra step, we will appreciate that. Good. Any questions up until there? We good?
Yes.
So, last one. Can we go for it? What is the challenge there?
Kids.
Brackets. So that means we first need to do what?
Okay.
Expand the bracket. In one bracket we have
X plus 1.
x plus 1,
3x minus 7.
3x minus 7. Alright, if we distribute this brackets or expand the brackets, what do we get? X squared, let's do it, x plus x is going to be negative 7x plus 3x minus 7, like that. So d of x, if I simplify it, is going to be equals to x squared minus 4x minus 6. Right? Oh, 3x squared. Thank you. 3x squared minus 7. Good. Then we go here and we say, oh, this one now is going to. Now the answer to this is easy. We don't have to expand further. That we can differentiate. The answer there is going to be 3, 2 times with 3, which equals to 6x minus 4. So we're moving on now to the next part. Now we have some questions. They want you to do that questions. I'm here for assistance, so I'm going to give you a few minutes to do that questions on your